Hello and good evening, everyone. I welcome you all to the SLIITXtreme 3.0 technical session. I am Manit Fernando and I will be your host for today. So today's session is brought to you by the IEEE Computer Society of SLIIT in collaboration with the software engineering student community. And we are thrilled to have you with us tonight. Slide, please. So if you have any questions or any doubts that you want to clarify, please feel free to drop them to the chat. We'll answer your questions at the end of the session. We'll be having a questionnaire. So if you're interested in joining the competition or would like to learn more about our initiatives, you can visit the website given in the slides, or you can just simply scan the QR code given below. All right, so we are delighted to announce that Cisco Labs of Sri Lanka will be our official knowledge partner. Their expertise will be an incredible asset to our event, and we are very grateful to have you with us. And to our official digital media partner, 𝗩𝗶𝘶𝗵𝗵𝗵𝗏 today, we are thrilled to have you with us as well. And we are very grateful to have you. All right. So to kick things off, we are honored to have a very special guest with us tonight. He has a wealth of experience and knowledge. Please join me in welcoming Mr. 𝗩𝗶𝘀𝗵𝗵𝗵𝗏. He's a lecturer in the Faculty of Computing of SLIIT, and he will be giving us an introduction to competitive programming. Mr. 𝗩𝗶𝘀, the stage is yours.
Thank you. I hope I'm audible very well.
Yes, sir.
Okay, great. So welcome everybody to this session. So give me a few seconds to share my presentation with you, and then we'll start. Okay. Can someone confirm if the screen is shared? You can see the presentation. Maybe the host can confirm whether they can see the presentation.
Yes, sir, we can see, sir.
Okay, great, great. Okay. So today the topic is on competitive programming, right? So this will be an introductory session to what competitive programming is and some skills that you might want to have if you are planning to engage in competitive programming, and maybe some resources that you can start with. So my name is 𝗩𝗶𝘀𝗵𝗵𝗵𝗏, and as introduced, I'm a lecturer in the Faculty of Computing in the Department of Software Engineering. So let's see what's in the store for today. Right, so this is what we are going to discuss, right? So we are going to start with what computer programming is, and then we'll see why you might want to engage in computer programming, right? Then we'll see some fundamental skills required, right? And also some types of problems that you will encounter in computer programming. Then we'll also see some sort of, let's say, advice on how to participate in competitions or contests, and then some resources that you can use to start your computer programming journey, and one or two examples, simple examples that I have with me from earlier contests. Right. So computer programming, very simply put, is an e-sport, right? Just like gaming and all these things that you do with the computer, you know, the fun things that you do with the computer. So similarly, computer programming is also considered as an e-sport. Its history ranges back into 1970s, and with the advent of the internet, competitions that were organized as local events became global events due to the internet connectivity. And today we have many prestigious competitions running, computer programming competitions. And when it comes to computer programming, simply put, what you do in computer programming is to basically solve computer programming problems or algorithmic challenges using your programming knowledge within time and memory constraints. So basically, you'll be given a problem to solve, and you'll be given a set of constraints or conditions that you have to align with. You'll be bound by these conditions, and what you have to do is you have to come up with some sort of a code or an algorithm written in some sort of programming language, which will solve this problem while staying within the boundaries given, right? Usually it's time and memory constraints, so we'll briefly touch upon them during our presentation. But since this is an introductory presentation, I won't be going into much depth. But since you're going to hear a lot of things in this, I think it will be better or excellent for you to maybe take down notes and search on these terms and keywords that I mentioned in this presentation. Okay, so as I said to you, a lot of competitive programming competitions take place on the internet today. So there are many popular platforms which hold these contests. For example, I think the most well-known ones in SLIIT are HackerRank and HackerEarth. But there are many other, like there's a whole list, right? So I have listed only a couple of things here. Right, now we know what computer programming is now. So let's see why engage in computer programming. Well, to give you the best benefit of computer programming, it basically improves your capabilities in handling logic, algorithm design, and coding efficiency. That's that, right? And it also improves your skill in solving problems under pressure, right? That's an important skill to have, and it will be very valued, especially in the industry. And this is an excellent place to develop that skill. And all, of course, winning prizes and bragging rights, right? Winning and participating and winning in a computer programming competition is no small feat, right? So you obviously have the bragging rights if you do happen to win. However, it takes a bit of practice, but with practice, of course, you can without any issue, right? You can win without any issue. Now, and of course, the cash prizes that you receive today in most computer programming competitions, it's substantial, right? So of course, there's a financial incentive as well. For example, I think last year, the SLIIT Algothon contest, which was held under the Code Fest, I think the first place received, if I'm not mistaken, 50,000 rupees. That was won by a group from University of Colombo School of Computing, if I'm not mistaken. But they won that in like 5 hours. That's it. So 5 hours you come for a competition. At the end, you walk away with 50,000 rupees. That's it. So that's the like the normal end of the scale, but there are competitions, especially international competitions, which are going to give you much bigger cash prizes. So there's that benefit as well. Now, when it comes to competitive programming, there are many competitions. So the reason why we are here today, that is SLIITXtreme is one such competition, right? And as I heard from the organizing team, it is actually quite related to IEEEXtreme as well, which is a very well-known international competition which runs for 24 hours overnight, basically. So as I understood from the organizing team, SLIITXtreme is like the gateway to the IEEEXtreme for SLIIT students. So all in all, it's a very nice chance for you to experience what computer programming is, and I encourage all of you, whether or not you think you have top-notch skills, go and participate. There's no harm in that, right? So we'll see what sort of skills you need to polish and have when you go into, if you are very serious about competing. But definitely brushing up on these skills will definitely help your programming skills anyway, whether or not you're going to go into computer programming, right? Let's see. Now, when it comes to competitive programming, there are some fundamental skills that you have to develop, right? So I have listed some of them here, the most basic ones, right? So starting with data structures, algorithmic thinking, understanding time complexity, and debugging, right? And teamwork, right? Now, some of you must be wondering, okay, as far as we understand, it's something to do with programming. So programming tends to be an individual operation, individual activity. How come teamwork is a part of competitive programming? You'll see. Wait. Right. Now, when it comes to basic data structures, I'm pretty sure that most of you are aware of your data structures. Not maybe if you are a first-year student, but the rest of you, I'm sure that you have heard these terms before. But even if you are a first-year student, nothing to worry, right? Information is always available online, and you have lots of avenues for looking up these things, right? So make sure you use Google and ChatGPT and all these resources available to you, and look them up, right? So when it comes to competitive programming, it's important to have an understanding about basic data structures. I have included strings here as well, but string is not a data structure, if you can understand, right? So when it comes to competitive programming, it's important to know how to deal with arrays first and foremost, because that's something you are going to encounter almost always. That's like a given in any question, any challenge. It's like a basic building block. So know your arrays and strings. Well, string manipulation is also a basic building block when it comes to competitive programming. That is, sorting strings, then rearranging strings, things like that. So then we have stacks and queues, right? Basically, they are used for problems involving order and sequencing, right? Dictionaries or hash maps, right? Basically, you use them for storing values as key value pairs, and for fast lookups, etc., etc. Then you have trees and graphs, basically structures used for connected and hierarchical data, right? So it's best if you get a basic understanding about these things before you start attempting something to do with competitive programming, right? And obviously, I haven't mentioned it here, but obviously, you need to have some practice with a programming language. So that language can be anything quite familiar to you. Now, some people say if you're doing competitive programming, you should do it in C++, or something like that, C perhaps. Well, I tend to take the view, right? So what's important when it comes to competitive programming is developing your skill, thinking skill. A programming language is used only to transform an idea that you have in your head into a program. So if you are familiar with the programming language, this process of transforming the thinking, the pattern in your head into a program is faster. So, and almost all competitive programming platforms available today, I mean the major ones, support almost all the major languages. That includes C++, obviously is there, Python is there, JavaScript is there. If you want to use C#, it's also supported mostly. Java is supported, obviously. So likewise, if you are familiar with any of these languages, just be kind of get more familiar with it, know the nuances and everything. So the language should be, you should know a language, a programming language, obviously, to be able to code, but there are no specifics when it comes to programming, the competitive programming, right? You can use any language you prefer as long as the platform, the competition platform supports it, right? Now, then we have another fundamental skill that we require, that is algorithmic thinking. So this is, in fact, I would say the most important, one of the most important skills when it comes to competitive programming. So algorithmic programming, algorithmic thinking simply means understanding a given problem and then breaking down the problem into manageable parts, and then designing some sort of an algorithm, or let's say designing some sort of a solution in order to address that problem, right? Come up with a design and then implement it, and then run and fine tune and make corrections as long as until you finally solve the problem. Now, so there are some things that you need to do when it comes to algorithmic thinking. So this is something that you practice every day as an IT student, right? So you are always in, I think in almost all your modules, you are given problems to solve in terms of projects and assignments, right? So this is nothing new to you, right? In fact, I think you have had many programming modules as well. And in fact, you have had modules which specifically focused on algorithms. So this is nothing new for you. Even if you're a first year student, this is not new to you, because I'm sure that in your introduction to programming courses, you have discussed this, right? How to think and formulate a program. Well, so when it comes to algorithmic thinking, one of the first things that I would advise you to do is, when it comes to computer programming, is not to start coding right away whenever you are given a problem. Don't do that, right? So I think this is a practice among students when it comes to assignments also. Whenever you are given a problem to solve, don't start writing code straight away, right? That's not going to solve anything. Maybe, just make you feel better, but not going to solve anything. Think, stop, read the problem, right? The given problem, try and understand it very well, right? That's the most important point. Understand the problem very well, and while reading, try to see whether you can isolate parts of the problem into different boxes, right? Basically, I'm telling you to decompose the problem into smaller parts, right? And once you have some sort of a understanding how these boxes would interact with each other, and then how this interaction would solve the problem, take a piece of paper, write it down, right? Draw a picture, draw a diagram, do whatever necessary to make you clearly understand the solution that you have come up with, right? Once you have the solution, then you can start writing the code. And you don't have to pause and think when writing. The code will come to you naturally. Just have to look at the design. Since you have the design in your head and you have written it down and you have made adjustments to it, the code is going to come like nothing, right? You will be able to just type it out, right? So that is where you will require proficiency with the programming language as well. But the most important point here is thinking, right? So when it comes to competitive programming, the way to improve algorithmic thinking is practice. There's no other way, right? You have to solve problems regularly, and you have to study existing algorithms as well. For example, let's say you have been given a question to, let's say, okay, I'll take a simple example. To find the shortest path between 2 points. Now, basically this is what algorithms like Dijkstra's algorithms do. Now, if you didn't know that such algorithms existed, you'll have to think and think and think and maybe come up with something in the given time, but it might not be completely satisfactory. But if you knew that this particular algorithm could do something like this, then it's a breeze, right? So you have to study existing algorithms as well, right? So I mean, many resources are available online. I haven't listed anything here, but you can just Google the term, algorithms, maybe many resources are available on YouTube as well. So make sure you study algorithms as well, so that they will help you sort of give you a template to solve most common problems, right? And don't start coding straight away, which I just explained. Think, formulate a solution, and code the solution, right? That's the most important part. And when it comes to coding specifically, one of the so this won't always work, but one practice that I found to be quite easier to manage is basically just brute force first, then optimize. Don't try to write optimized code in the beginning, but just write what you figure out, right? For example, I'll give you a simple example, right? Let's say you need to print a certain line 5 times. If it's going to work, just copy paste the line 5 times, right? And if it's working, then perhaps you can consider using a loop there later when you're optimizing the code. But as long as it gets the work done, it's okay to leave it as it is. But remember, this is only for competitive programming. I didn't mean to say that you should do something like that in actual work environment or actual assignments as well. But when it comes to competitive programming, time is of essence. So optimize only what is necessary. Don't optimize everything. There's no need, right? As long as the solution works, as long as it satisfies all the given test cases in a competitive programming challenge, that's fine, right? So what's a test case? We'll see, right? Don't worry about that. I'll explain what it is when we go into examples. Right, so that's what I have to say about algorithmic thinking. And another important topic that we should focus on when it comes to competitive programming is especially programs that we are writing in this sort of a competition is having an understanding about time complexity as well as space complexity, which I do not quite discuss here, but time complexity basically stands for it's a measurement against how complex your program becomes as a function of basically inputs, right? So you all have heard of big O notation, especially I think the third years, fourth years will definitely know. I think second years will also have, I think they have a module on that. First years, I'm not really sure, but of course, Google is your friend. You can go ahead and Google this. You'll find plenty of websites, YouTube videos, books, etc., explaining what big O notation is. Now, this is something you have to be concerned about. Why? Because usually in a competitive programming challenge, you're sometimes given constraints, right? I said to you that you are given constraints. So sometimes you are given time complexity constraints. For example, the solution that you come up with should be like of O(n) complexity, like O log n complexity, right? So something like that. So you might come up with the correct solution, but if it does not satisfy this time complexity requirement, then the solution won't be accepted. So that's there. And then there's space complexity as well, which basically, in simple terms means the amount of memory required to run your program. So sometimes in programming, these challenges, you will have a space complexity as well, right? So this particular solution can only take 1 MB of RAM, nothing more than that, something like that, right? So your solution, in addition to solving the problem that was mentioned in the challenge, should also satisfy these time complexity requirements and space complexity requirements if given, right? So that is why you need to be having a good understanding about how to deal with these things, right? Right. Okay. Now we come to one of the more other important things when it comes to competitive programming. That is your debugging skills, right? Yeah, of course, we are going to write programs, but we have to, nobody's going to write a program that's going to work in one attempt, right? One go. So you'll have to debug it. You have to fix problems that you are going to encounter. And then only you'll be able to come up with the program which is going to satisfy the given challenges, test cases, right? So the first thing that I would advise you to do when it comes to programming competition is to review the programming, the problem statement of the challenge carefully, right? Read that challenge carefully without doing anything before you write your first line of code, right? Do nothing, just read. Read and understand that problem statement very well, right? You can even get the help of your teammates as well, right? If you are not clear about something in the problem statement, talk to your teammates, ask them what it means to them, and get a very clear understanding about what is required from you in solving this problem, right? So that's step number one in avoiding misinterpretation, right? Then only you can come up with a proper solution which you can then code in your programming language and submit, right? So that's the most important point. Don't rush into writing programs. Even if you're in a time constrained environment, there's nothing you're going to gain by rushing, right? Except maybe problems. So don't rush, read, understand, then think. Remember algorithmic thinking. Think, come up with a solution, and then code the solution, and then check and submit, right? Check to see if all the test cases are satisfied with your solution. If not, rework your code and then submit as soon as you get your code satisfying all the test cases. Well, when it comes to debugging, another important point is to write clean modular code to help with debugging. Now, obviously, if you are writing, your solution in something like Java, you don't have to write your program. It's like you don't have to separate your program into different files and have some sort of a good package structure. No, none of that is necessary because you're going to submit only just one file. That's all, right? So everything is going to be in just one file. So there's no need to like separate out your code. But what I mean by modular is basically group together related logic and keep good spaces in between these lines of code so that it will be easy for you to read the code and understand when you're debugging, right? And make sure you use basic good programming practices which we have been discussing since the first day itself, right? Have good variable names, right? Don't just name variables with just one letter. Don't do that, right? Have proper variable names. Name the constants using capital, uppercase letters, and follow one variable naming standard, etc., etc. And before submission, you need to test your code with various inputs as well as edge cases as well. So what's an edge case? Basically, edge case are special circumstances. For example, let's say you take a calculator app, you build a small calculator app. So, you can feed various inputs as numbers to this, right? So you need to see whether, what happens when certain special inputs are given. So think of that as an example. Special input meaning, let's say you give a huge number and see what's going to happen, whether the program is able to handle that, if the answer is correct. Likewise, right? Use print statements and debuggers to trace logic errors. Now, that's obvious, I think, right? You can use print statements and, debugging, breakpoints and all you have in your tools. That is, IDEs to like trace errors and, see what's happening and, do whatever fixes necessary. And that's that. And of course, when you're programming in a competitive programming competition, there are various rules. For example, some competitions won't allow you to leave the competition, the window. If it's on a web browser, it won't. If you leave the window, that will be a point for disqualification. But there are some competitions which are okay with you leaving the competition, the window, and coming back to it later. So I'm not really sure about IEEEXtreme now. And SLIITXtreme, the organizers will have your answers there. If you have any questions about that, go and ask them. But at least IEEEXtreme sometime back used to be of second type. That is, you can leave the competition window and come back without any penalties. So what we used to do when we were engaging in these competitions was we didn't write the code in the given window. That was my personal preference. But instead of writing the code in the given window, I wrote it in a IDE, which I had on my own computer. So that really helped me with debugging and basically coding. So once I'm happy that this program is satisfying all the given conditions, I'll just copy and paste the code into the submission window on the competition window, right? So, and then I'll just evaluate it and see whether everything is okay. And then I'll check the submission, right? You have options for like checking the submission and then submitting it. So when you click on check the submission or something related, basically your code will be taken and then it will be analyzed against a set of unknown test cases. You don't know the test case, but only they know it. The organizers know it, but not you. Your program is taken and it is fed some unknown inputs by the competition platform. And then the result will be given to you, whether the program successfully executed each test case. If everything is okay, you can go ahead and submit. If you get one or two test cases wrong, it's always better to like check and see what's going wrong. But if you are pressed for time, and you see that most of the test cases are passing, you always have the option of submitting it. No issue with that, but you're going to get a reduced mark. That's it. But usually speaking, the higher the number of test cases that your solution passes, higher the mark, right? Higher your score. Now, when it comes to debugging, some common errors that you need to understand now. Well, one very common error is actually off by one issue. Basically, this happens with indexes in arrays, loops, right? And checking ranges. Like, for example, if let's say you check for something that is, you check for an index which is not available in the array. For example, if you have an array of length 4, you have indexes starting from 0, 1, 2, 3, right? So you check for an index of 4, which is going to result in an error. So see if such things are available, right? If you see such things, that's something that you need to fix. And another cause of problems is uninitialized variables. Now, that's a normal programming practice to like initialize your variables and use them, but make sure you do that. Then another cause of problems is null values. So sometimes you will write the program thinking that a certain variable will always get a value, but during the program's execution, sometimes the value, this variable will not have any value, right? There's nothing, null. So when there's a null condition, your program will go into a, if you haven't really specified what to do, if there's a null situation, your program will end up in an error situation. So you have to handle those as well. So this is actually applicable when you're working with mostly things related to object-oriented programming. But just know it's always good to have some sort of a null check when you're dealing with different object references. So make sure. So those are some things that I could list right now, but there are many, I'm sure, right? So that's for debugging skills. Then most importantly, teamwork. Well, now you must be wondering, as I said earlier, well, programming seems to be an individual activity. Then why teamwork is necessary? Well, because usually competitive programming competitions are held as team games, right? You are given a list of problems to solve and a certain time limit. Let's say you have been given 10 problems, 5 hours to solve. No individual person is going to solve these 10 problems in 5 hours, except if they are like especially gifted. That's like not humanly possible, right? So I have seen such people. In fact, I remember seeing somebody like that, somebody very close to being somebody like that in one algorithm competition. That was a SLIIT student, by the way. So usually algorithm had a team size of 3 people, but this person wanted to compete as a single participant. So we allowed, and when all other people, all other groups with three people in them, like competed, solving like 10 questions in, I can't remember the number of hours, but let's say it's 3 or 5, right? This person solved like 7 out of 10 within the given time frame on their own. So that's a very good level of skill to have, but that's quite like, it's not the norm, it's an exception, right? So long story short, competitive programming competitions require teams to successfully solve the given challenges in the given time frame. So that is why, even though programming is sort of an individual, let's say, activity, still you require a team when participating in competitive programming, right? So there are certain things as a team that you need to do when you're in competition. So number one, when you're in a competition, the number one thing to do is to communicate very clearly. This is where people go wrong, right? You have to communicate very clearly about the state of your, let's say, program, the level of completion of the challenge that you're working on. If you are like encountering an issue, you have to communicate that clearly to your team members, right? And even if you're taking bathroom break, make sure you know your friends know, right? It's as simple as that. Openly communicate, right? That's number one. Number two, divide responsibilities. That is, as I said to you earlier, no single person is going to be able to solve all the given problems within the given time frame. You might be able to do it if you have been given more time, but the aim of a competitive programming competition is to restrict the time and see who's going to thrive under pressure and reward them, right? That's the point. So basically, in such a situation, you will have to divide responsibilities. Like, okay, who's attempting question number 1? Who's attempting question number 2? Likewise, you have to decide that, right? And sometimes you might even decide, okay, both member 1 and 2 both will attend question number 2 because it seems to be a bit difficult. Likewise, you can divide that responsibility and stick to that responsibility, right? So in order to do that, an understanding about each member's strengths and weaknesses would be beneficial, right? So this sort of an understanding, of course, comes with practice. I mean, if you're a first-time team who's going to participate in a competition such as this competition, that is SLIITXtreme, you might not necessarily have the understanding about each member's strength and weaknesses. That's totally fine, right? This is something that you will develop as you go on, participating in many competitions. So there might be a member who's like good at good in solving certain types of challenges, right? Maybe they are good with dynamic programming. Then there's the other guy who's like very good with graph theory, and then there might be another person who's good with mathematical problems, right? So know the strengths and weaknesses. Always try to play to your strengths. So if there are challenges in the mathematical domain, and you have a person who's like good at that, obviously try and give the question to them, right? If that's not your forte, give it to them, and you take something that you can do, right? You are confident in. So that might not always be possible, but try to do that, right? So in order to do that, you have to know each other's strengths and weaknesses, right? Get help from teammates when necessary. Now this is an important thing to do, right? So this is something I need to highlight. So once the competition starts, you divide the questions among yourselves. You might think, if I am to like ask them for help in solving a particular problem that I encountered with, let's say, question 1, it might look bad on me because that might make me appear kind of unskilled. No, that's not a good mind. That's not necessarily true. And that mindset is something that ethically to win the competition. So sometimes, even if you are a very well versed person in programming, still you might not, let's say, see things in a clear manner sometimes, right? For example, let's say you develop a solution for a challenge, let's say challenge 1, and then you are okay with up to a certain extent in the solution, but there's this one part you can't figure out. Well, you can spend hours thinking about it, or else you can go and talk to your friend, right? Look, I have this problem. What do you think about this? How I'm at a loss here. I don't know, really understand how I can get past this point. When you go and talk to your friend, what's going to happen is they are going to give you a different perspective, right? They have not been a part of this problem, so they are coming up with fresh ideas. So because they are not burdened by this responsibility, they might freely tell you, okay, try doing this, try doing that, try doing this and that, etc. And I can guarantee you, this sort of brainstorming and just suggesting things lightheartedly will definitely help you find a way. It will give you sort of an idea. It might give you the breakthrough that was required in order to go past that point, and you will be able to solve it that way. Still, it will be your win because you just got help from somebody when you were stuck, but it's mostly your contribution. But that person also contributed your win as well. So it's a group activity, it's a teamwork. So get rid of the mindset of I have to do this on my own, otherwise it will be shameful. No, that's not the case. Get help whenever necessary. Help your teammates also when necessary, and get things done, right? And I have to tell you something about the usage of AI tools here as well, right? Now, maybe you should, I don't know, I'm not very aware of the policy on tools such as usage of policy of tools such as ChatGPT when it comes to SLIITXtreme. But practically speaking, please make sure you align with the competition rules. So some competitions might allow it, some competitions might not allow it. So it will be up to you to ethically ethically correct and align yourself with the given guidelines, right? So if caught there will be penalties, including expulsion from the competition. So, I mean, that's not a good thing to, do, right? So make sure you align with the given rules and regulations and see what the policy on usage of AI tools is, right? If it's okay, yeah, fine. Then totally fine, but make sure you check on that, right? Right. So that's how you should behave in a competition. And when you're outside a competition, what should you do? Well, we have a list here. Competitive programming is all about practice, right? This is all about practice. Yes, you can be a good coder, but how good you will be under pressure? That's what is actually tested in competitive programming. So you should practice coding under pressure to see how good you are, right? So always engage in practice sessions. You can use these online platforms. For example, HackerRank has loads of practice questions, practice competitions, right? You can even create your own practice competitions as well on HackerRank, and even HackerEarth is, I think, allows that. So do that, right? That's the number one thing that you should do. Practice will be the number one fact that will make you a good competitive programmer, right? And number two, learn from others by discussing solutions post contest, right? Once the contest is over, don't just close your laptop and you think, okay, this is done, we'll just go home now. Yeah, you can do that, but at least maybe after the day after the competition, get together and discuss what you came up with the solution, right? And maybe ask others for feedback on your solution, right? That's how you improve. Don't be scared of getting criticism and feedback, because criticism helps you improve, right? Just discuss, get criticism, give criticism. Of course, I mean in a positive manner, right? Give constructive criticism. Don't just something bad about them. That's not what I mean here. What I mean is, think about the code that they have written. Think about the algorithm that they have thought. Think about the approach that they have taken and critique that constructively. Constructively meaning okay, if I put it in simple terms, constructively means, okay, look at a given, let's say, piece of code, list the problems, and then also say how the said problems can be improved. Give the suggestion, right? Don't just criticize and stop there. So that will make you think as well, thereby improving your own skill as well, in addition to helping some other person improve their skill, right? So it's a win-win situation. So make sure you do that, right? And engage in online forums, right? There are many online forums. For example, I think HackerRank again has one, and I think I have listed a list of available resources. So a lot of Reddit has, I think, as an active community when it comes to this, and Reddit almost, I mean, Reddit has anything, I mean, Reddit has subreddits for anything, right? So there is one for competitive programming as well, I'm pretty sure, right? And you can check Stack Overflow as well, even though it's not a competitive programming oriented platform. Stack Overflow will help you, with programming. And finally, it's all about practicing, right? So build study groups and solve problems together, right? Gather with your teammates, gather with other teams if possible, right? And have some sort of unofficial gatherings. It doesn't have to be an official competition always. Get together with your friends, maybe from other universities, get together and solve problems, see how they solve the same problem in comparison to you, and learn from them. Always learn from the others, right? That's something that you have to do, right? So I think those are some fundamental skills that you need to have when it comes to competitive programming. Now we will see some types of problems that you will encounter in competitive programming. So I don't think this list is exhaustive, but these are the most common types, right? So when it comes to computer programming again, I said to you, you get challenges, right? Basically, there are questions which you need to like find answers for. We call them a challenge. So you can actually like categorize these challenges in into different problem types, mainly these types that I have listed here. But a challenge could belong to several of these types as well, right? So I have just listed some types here. I'm not going to explain each and everything, but we'll just go and see a few of them, right? So the sorting and searching, right? So that's like one of the most common types of challenges that you would get, right? Basically, things to do with sorting a set of numbers given, right? Or just checking if a number of, if a given array is sorted in a certain order. Maybe find the third highest number in a given array and see if it's a positive number or not, or maybe see if it's a negative odd number or an integer, sorry, odd number or an even number, right? Likewise, those problems will come under those, sorting and searching. And then string manipulation, obviously, right? So it's like, again, one of the most basic types. You will be advised to like take in a string and maybe find count the number of characters in the string, right? So like if we take the word, let's say hello, right? HELLO. So how many characters of each type are there? Like let's say you have been asked to find. So there's one H, one E, two L's, one O, right? So likewise. So that's something to do with string manipulation, right? So maybe I think that was too small to be string manipulation, but if it was a sentence, perhaps, yeah, right? Data structures. Again, we talked about data structures before, and you will be sometimes given challenges which you will have to solve using different data structures, right? Stacks, heaps, etc., linked lists, whatnot. So then there will be like challenge like backtracking, divide and conquer. Like backtracking simply means iteratively trying out different parts on a in your program, and then if one doesn't work, you take a step back and take the other path and finally find the path that works. So one simple example I can give here is trying to solve a maze, right? So you know what a maze is, right? So you have an in and out, and between the in and out, you have basically a very complicated path. I'm pretty sure as children you have kind of traced pencils. Find the way out of the maze, right? So if you have to write a program to find a way out of a maze, this is exactly what you're going to do, right? So you are going to follow a path. No, it's not. When you realize it's not going to work, you're kind of come back to the last junction you were at, then follow the other path, and then maybe it leads to another junction, then go to another path. Likewise, you would go and go so on and so forth until you find the exit, right? So that's backtracking for you. Then you have divide and conquer. It's again a strategy in solving problems. So divide and conquer simply means dividing a complex problem into independent, simpler, more manageable parts and solving them individually and gathering them and then coming up with the overall solution, right? And then we have something called dynamic programming as well, which is it's almost similar, but there's a slight difference between dynamic programming and divide and conquer. However, it's very important that you understand that the difference is oftentimes when it comes to dynamic programming, you also divide and conquer, you take a complex problem and break it down into more manageable, simpler tasks. But oftentimes these tasks are kind of related to each other, right? They are overlapping. But in divide and conquer, they are independent, right? In dynamic programming, they are like overlapping. So that's the biggest difference, right? So that's an important difference to understand, right? So then you have graph algorithms, mathematical problems, etc. So mathematical problems, now don't be scared when you see the word mathematical, because this could be, you know, something very simple like find the biggest number from the list, and it could go up to very heavy mathematics as well. That's true, but there's a huge range here, right? You all have studied mathematics, right, at schools, and you study mathematics in the, I think, in the first 2 years, if I'm not mistaken, maybe in the first year. You study discrete maths and probability and statistics, etc., right? So you have a good background to attend to mathematical questions as well. So these are some types that you might encounter when it comes to competitive programming, right? Right. Okay. So now we know the types as well. Now let's see how we can participate, or what should we do if we want to participate in contests, right? Well, number one thing to do is, of course, to practice problem solving, right? Use whatever sources available online and practice, right? And make sure you analyze both your own and other solutions. Now, I think some platforms give you the ability to check your solution as well as other people's solutions to the same problem. Then you can see what things that you have done right, not, and what other people have not, versus what you haven't done right versus what other people have done right, right? So make that an opportunity for you to learn, right? Learn and incorporate those practices into your code. That is how we are going to improve, right? Now, success in competitive programming is not going to happen overnight. So it's going to be a gradual process. However, you have to start somewhere. So if you have no idea what competitive programming is, I really recommend you join the SLIITXtreme competition and see what it is like, because it's our own university's competition. So you can always join and see what it is like, right? And there are many other free competitions online as well. So make sure you go and check. I think we can't emphasize this enough. Practice. That is what's going to make you great, right? And when it comes to practice, it's rather better to like practice regularly a bit, like, every day, like dedicate maybe 30 minutes for this practice, versus put 7 hours every Sunday. I mean, both are beneficial. Beneficial over not doing anything, but I think doing something daily, even though it appears small, will be better for you in the long run, right? So make sure you practice regularly. And one thing I would like to add here as well, that is, be familiar with the competitive, the programming platform that you are going to use. For example, find out beforehand what's the platform you are going to use. That's usually advertised with the competition. For example, if it's going to be HackerRank, go and log into HackerRank and familiarize yourself with the interface and the commands, the controls, etc. Right? That way, when you go into the actual competition, you won't be at a loss. Right? Make sure you do that. I mean, there's no restriction in against that. So make sure you do that. And when it comes to the competition itself, managing time is important, right? So one of the most important things that I think that you need to practice is to know how much effort you need to put into a problem, and to know when to move on from problem, because sometimes despite our best efforts, we might not be able to solve the problem completely in the given time, right? Not in the given time, but we won't be able to solve it, right? Let's say the competition is like 5 hours long, and we have 10 problems to solve, and each person, let's say, to make it easy, we have a team of 4 members, and let's say 8 problems are there. So each person has to solve 2 problems at least, right? So 2 into 4, it's 8. So each person has to solve 2 problems at least. And let's say you have, yeah, 6 hours for it, right? So that means you are going to have roughly like 3 hours for each problem, individual, I mean. Now, that means, roughly speaking, you can spend 3 hours on each challenge that you have, but practically speaking, the difficulty in each challenge will be quite different, right? So sometimes you might be able to like spend 4 hours on the harder one and maybe 2 hours on the easy one. Likewise, you'll have to understand and manage the time likewise. But let's say the hard question, even after spending 4 hours, let's say 4.5 hours, you still can't figure it out. Well, then you should know that it's time to move on from that problem for the time being, right? Because why? Of course, yeah, you might solve it and get the mark, or else you might not solve it by the end of the competition, thereby not gaining the mark for that, plus not gaining the mark for the easy one as well. So the better option would be to, like, after 4 hours, if you still think that you can't figure it out, stop working on it for the time being, jump to the next question, and try and do it as fast as possible. And then once you're complete with it, if you still have some more time, jump onto the half completed hard problem. If it still has any issues, well, nothing to do. Just look at it after the competition and see how you can manage that. But still submit it, right? Submit it to the competition, because by submitting, if at least your solution like passes at least one test case, then you will at least gain the assigned mark for it. So don't not submit anything, right? Submit everything that you create, right? So this is an important skill to have, right? How to manage time and to know when to move on. So make sure you practice this as well. And finally, failing is very natural when it comes to this game, right? It's there. It's going to be there, right? So what you need to adapt here is a growth mindset, right? Don't think once you fail, okay, I can't do this. I'm not cut for this. No, that's not the point. You can't do this now, true, but with practice, with a bit of time spent on doing this, you will be able to do it. Therefore, when you can't do something, don't be discouraged, but just be at it. Maybe after the competition, take your time again with a fresh perspective, attempt this again, and you will overcome it, right? So it's very important to have this growth mindset as well. Right. So with that, we actually come to the end of the presentation. I have listed a series of links here for different resources. So HackerRank, HackerEarth, CodeForces, Coder, these are all competitive programming platforms. LeetCode is not exactly a competitive programming platform, but it's rather a platform people use to prepare for interviews, coding interviews, basically. However, it's still beneficial because it lets you practice problems on your own, and it lets you analyze those solutions against other people's submissions. So it's beneficial. That is why I have included it here. And Project Euler, I think some people call it Euler, some people call it Euler. Anyway, so Project Euler is an interesting one as well, because this basically contains mathematical problems. However, these are not problems for mathematicians, but people who have some sort of an interest in mathematics plus computing, programming basically. So make sure you check this out if you are interested in that area. just because you know mathematics, you won't be able to solve this, because you need programming language, programming knowledge as well. And I have to tell you, you don't need like mathematical knowledge, as in you don't need a formal mathematical knowledge to attempt all the questions in Project Euler. There might be ones, but you can always start somewhere, right? And in my search for different resources, I encountered this book also today, and I just referenced kind of some pages of it, and it seems to be a very good resource as well, and it's free. You can Google this name, right? And that way you can find the book. It's freely available on their website. Perhaps you can take a screenshot if you want from this and maybe save it for later. Well, yeah, right. So with that, we come to the end. So now I'll show you some examples of some competitive programming competitions that we conducted, right? And I have participated in. So I'm going to show you some challenges, what they look like, right? Right. So this is the first one that I'm going to show you. So it might look familiar to some of you if you have attended PAF, programming applications and frameworks. Sorry, programming. PAF IT30 module. Maybe in the last year. So this is actually from a small quick competition that we held for this module in the last couple of years. So it's very simple, right? So, but it still follows the structure of a competitive programming competition, right? So this is what you're going to get usually when it comes to a competitive programming challenge, right? So what you have here is basically a question or a challenge, which basically states that you need to write a program that reads in an array of integers and determines if it is sorted in an ascending order. Right? So basically, you need to take in an array of integers and check whether it is ordered in an ascending order. And your program should define a function called isOrdered that takes in an array of integers as input and returns a Boolean value indicating whether the input array is sorted in ascending order, non-decreasing meaning ascending order, right? Then, so this is what need to do. But this is what is needed to be done. Then you are being given certain like guidelines. Okay, what is the input format? The input consists of a single line containing space-separated integers representing the elements of the array. Then you have the constraints, right? The constraints are the length of the input array will not exceed 10 to the power 5, right? So only this many integers, nothing more than that. And each element in the input array will be an integer between this range, including these numbers, right? So what this means is whatever that you give in that array will be an integer between these ranges with these limits included, right? Then you have been given a guideline on output, right? So the output is either true or false because you are supposed to like output a Boolean value. And then here you have some sample test cases, right? So this is a sample test case. This is another sample test case, right? So you have a sample input here. So it's a series of integers, right? 1, 2, 3, 4, 5. And the output for this sample input is true. Well, why is that? Because we want to check whether this given input is an array which is sorted in ascending order, in which is in this case true, right? So it is sorted in ascending order. So which is why it is given as true here, right? And you are basically given an explanation here as well, right? And similarly, for sample input 2, you are given the output false because it's not sorted in a proper ascending array, ascending order, right? So likewise, then you have a simple answer here as well, but that's not necessarily our explanation. And usually this is the format that you are going to get when it comes to a competition like IEEE and I think even SLIITXtreme, right? Maybe, of course, the competition, the challenge might be a bit more complex than this, right? But the format will more or less will be quite similar, right? And I said to you, you will be shown some test cases which you can check, and you will also have a set of test cases to pass which won't be visible to you, right? So these are the ones that won't be visible to you according to this, right? So this is an actual design document that we created, so that is why this is visible here, but in the actual programming platform this won't be visible, right? So for each test case there's 1 mark, right? So altogether this question carries 3 marks, right? So for each passing test case you get 1 mark. So this won't be visible to you, but if you write your program correctly, these test cases will also pass without any issue, right? That's what competitive programming challenges look like, simply put. Now I'll show you what an actual competitive programming question looks like, right? Now, this is a question from IEEE 2016, I think, IEEE 10, right? So it has a success rate of 50%. Now remember, this is a competition that was available worldwide, right? So out of all the people who attended, like 1,048 people attended this, only 50.86 people got it right, right? So that's how it is. So that is why I tell you, don't be discouraged if you don't get right, right? Because always, you can always improve. Okay, so now look at this. So it's a very lengthy problem, right? You have a lot of text explaining what needs to be done. Then you have the input format. Then you have constraints. Then you have output. Then you have sample input and a sample output and an explanation, right? So, and you have some sort of a window here to like type or even paste your solution. And then you can click on run code to check if your solution satisfies all the shown test cases plus the hidden test cases. And then you have the submit button to see, basically submit your code, right? So I won't go and explain this in detail, but simply put, what needs to be done in this question is, there's a certain food truck called the Yummy Goods, right? And the owner of this food truck wants to see who's within a 1 kilometer radius of this food truck, and they want to send an SMS to this people who are like located within 1 kilometers, within 1 kilometer of the food truck. So in order to do that, this owner has a data set containing the last known GPS location, or the latitude, longitude values, and a mobile number for each mobile number, right? So basically they have a list of a mobile number plus its last known lat long values. So your job is to find if a given lat long value is basically fallen within the 1 kilometer radius or not. Now, this is not a simple mathematical operation, because you have to remember Earth is a sphere, right? Therefore, you have been given a special formula to calculate whether this coordinate is within the 1 kilometer limit from the origin, that is a food truck, right? So you have been given certain constraints when it comes to calculating, doing this calculation as well, and you have been given some input guidelines, right? Input format guidelines, as in a timestamp will always follow the structure, right? And stands for month, right? And likewise, you have lots of criteria here. And then you have a sample input, basically the date, the time, and the lat long values and the telephone numbers, right? And the sample output is basically the list of telephone numbers which are within the 1 kilometer range, right? So this is what you need to solve. So all in all, it's a very interesting question. So if you want, you can try and attempt it. Pretty simple. You can do this, right? Take some time. You can do this. So those are some examples that I wanted to show you. Right? This is actually from a collection of tests, challenges that's given in IEEE Extreme version 10. You can actually find this entire ebook on Google, right? Just Google IEEE 2006 IEEE Extreme 2016 challenges, and you will get this PDF. Right. So with that, I think we can wind up the session, right? At least my presentation, that is, not the session. And I think it's time, if you have any question, it's the time to bring them up.
Thank you, Mr. Vishal. So, like you have said, if you guys have any questions or need further clarifications, please feel free to drop them in your chat, or you may unmute and ask them, as we are happy to address them and keep this discussion going.
Well, the chat seems to be silent.
Yes.
Okay, that's fine. Well, that's totally okay. I think you can always direct the questions to the organizing team if you have any, or else you can drop me an email as well if there's anything, right? So thank you very much. That's the end of my presentation. You can always drop me an email at vishan.j@slit.lk.
Thank you, Mr. Vishan. We are truly grateful for your presence and having to do this session in the midst of your valuable time.
Yes.
believe
Yeah, I think we just got one question, right?
Yes, we
Do we have
did.
time to answer it?
Sure, why not?
Yeah, good. Okay. How can we confirm that our written code is optimized? Well, it's like this. If your solution, right, if your code basically passes the let's say once you submit your code to the platform and the test cases pass, basically then you can consider that your code is optimized enough for that challenge, right? There's no one size fits all sort of a solution when it comes to saying, okay, this code is optimized or not, right? It's always depending on the challenge, right? The level of constraints on that challenge. But remember, when it comes to an actual programming situation, again, you'll have to see, I mean, I'm talking about an actual industrial context, right? In that case, you have to see, various other factors. But in this case, in competitive programming, as long as you satisfy the list of constraints given in the challenge, you should be fine. I think I hope I answered that question. Right. We have another question from 𝗩𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓. yes, okay. Yes, okay. Thank you for the confirmation, Mohammed Jasil. So 𝗩𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓, I think I believe I pronounced the name correctly. Right. Their question is, do all members in a team have to do coding, or one member submission is enough? Okay, good question. If you are registered as a team, as long as the team submits an answer, that should be okay, right? So that means if one person from the team submits an answer, that's fine. I hope I answered that question as well. Okay. Okay, so we are now with the questions are coming. Right. So when we are attempting the questions in the competition, do we need to attempt the question using one language, or else can we use any language? Okay, basically your simple question is you're asking whether you can switch the languages. Well, this shouldn't be a problem, right? For example, yeah, practically speaking, I have done this. Now, for example, in one of the competitions that I participated in as a student, I think my friend coded in JavaScript or Python. I can't remember now, but I think I used something else, maybe Java, or yeah, something like Java or C#. Can't remember now, but basically, yes, you can switch languages from question to question and person to person. No issue, as long as the platform gives you the option to switch the language to the language that you want, you should be fine, right? So if you are like going to program in a very obscure language, then it might not help, right? For example, now I'm not sure if languages like the very old languages like Pascal are supported these days. It might be, I don't know, but if you're like if you are going to write your program in Pascal, and if the platform doesn't support it, well, in that case, well, you have no option but to switch to a language that is supported. But almost all the main well-known languages are supported out of the box, so you should be fine. Okay. Okay, so Senali says, can you share quick questions of previous hackathons and example questions? Well, Senali, I think they're freely available on the internet, right? Just Google have competitive programming practice question. You will see thousands, maybe millions, right? Everything is available free of charge for you, right? There's no need to share anything. Just Google, you will find thousands, right? Basically, you'll have enough to practice and more, right? So there's nothing to worry about there. And if you sign up to some platform like HackerRank, they will also have their own like very guided programs to get you into like advanced versions of challenges as well. So you start with something small, a simple challenge, and then they will kind of give you challenges that gets more and more advanced as you go on. So you can try that also, right? I hope I answered that question as well. Okay. Okay, so do we have any more questions? Okay, it seems like that's the end of it. So thank you very much. So my email is here. If you have anything, you can always drop me an email. That's all.
All right. Thank you, Mr. Vishan, for this truly remarkable session. And we're also happy to see our audiences engaging with the hackathon of SLIITXtreme 3.0. So before we move on, Mr. Vishan, we would like to gift you the token of appreciation for dedicating your valuable time as a speaker for SLIITXtreme 3.0. We are truly remarkably grateful, sir. All right. So so before we end the session, we would like to invite another esteemed guest speaker, and that would be Mr. 𝗩𝗶𝘀𝗵𝗵𝗵𝗏. A little background about him is he was from Team Glory, a former winner of SLIITXtreme 2.0 that happened last year. So, Mr. 𝗩𝗶𝘀𝗵𝗵𝗏, your platform is yours.
Hello, am I audible?
Yes, you are.
Hi, everyone. I'm 𝗩𝗶𝘀𝗵𝗵𝗏. I've been doing competitive programming for the last couple of years, and as you know, I'm the last year SLIITXtreme winner. And I love doing competitive programming. It kind of changed the way I used to like think in real life problems. And I mean, today's big software company interviews, you need to be good at this. So yeah, I think Vishan's already covered most of the things, but there are a few things I had to say. So as he said, there are several platforms you can practice. You can practice problems and like Hacker, HackerRank, CodeSafe, Coder, Code Courses, and but the first round of SLIITXtreme is going to be occur in Hacker. Let me show you. I think you can see my screen, right? Can someone confirm whether you can see my screen?
Yes, we can.
Okay. So this is Hacker platform. For example, so the questions will be like in this format. It's very similar to HackerRank. So the contest will be in this. The problem will be in this format, and there will be a problem statement, input format, output format, and constraints. Okay. So for each problem, there will be some sample test cases, and there will be some hidden test cases as well. For example, I can show you some how questions are prepared in Hacker Earth, because like I used to work with Hacker Earth as a problem setter, so I can show you. I mean, these are the problems I created for Hacker Earth for some competition. So this is how preparing a question text. So this is a problem I made. So like here you had to put the input statement out, input format, output format, constraints, and sample input, sample output, explanation. Here I can like choose whatever language says. Does this problem have to support and all? And like each hidden test cases will have some score assigned to it. For example, I assign like for input one, for first test case 2.5 marks, likewise. So there will be like lots of test cases, maybe hundreds and like hundreds of test cases. It depends on the problem. Like if it's a hard problem, they make like lots of test cases because like they don't want to solve it. And as Vishan said, like you can follow some steps while you when you try to solve the problem. I can I mean my idea was also similar to Vishan, what Vishan said. First, like we have to understand like what's the problem is. By understanding what I meant was after reading the problem, like after understanding the problem, you need to know how to write a brute force solution for this. That's what I meant by understanding the problem. So let's look at this problem. So it's a Micro was playing with a graph gifted to him by his friend on his birthday. The graph contains n vertices and m edges. All the edges are bidirectional. On each vertex of the graph, there's a coin. Now, Micro has to collect them all, but the game has some rules. The player has to start with some vertex. From current vertex, player can visit only those vertices which are connected to it by an edge. Also, if a vertex is visited, it cannot be visited again. Now, Micro wants to find if he'll be able to collect all the coins. So, like after reading the problem, like if you don't get it, you like read a couple of times until you get it, because like understanding the problem is the important thing. So, like after reading this, kind of get an idea like what I had to do. But like before like coming to a conclusion like what you should do, like what you have to code or anything, you have to like check with the constraint whether like the idea is sufficient to code. So the next step, you have to look at the constraints. They given like the number of test cases is less than 10 and n is less than 10, say n is less than 100 and x and y are less than n. So like after reading these, like I kind of figured out like to visit all the vertexes, and I shouldn't revisit a vertex again. So it has to be a line graph, right? It has to be a linear graph, linear tree actually. And like based on the constraints, they given like as you like know about the time complexity, right? So they given n is less than or equal to 10. So like you can check all the subsets which you can create. For example, if n is less than or equal to 10 to the power 6 or something, you have to do a ON solution. If it's n is less than or equal to 10 to the power 8 or something, you have to think of an O1 solution. If it's around 1000 or n is around 1000 or something, you have to think of an n square solution. But in this case, n is less than or equal to 10, right? So you can like check each and every possible subset and find the answer. So like I kind of get an idea like what I had to do, right? So after this only, you have to consider like what are the algorithms or data structure I can use it to kind of optimize this. Because like when I was new to competitive programming, I learned lots of algorithms and data structures. So like after learning those things, when I like get into a problem, I usually think like what algorithm I can use here, right? What data structure I can use to optimize the kind of thing. So like for simple problems, I couldn't approach simple problems because like I always think around the algorithm, right? So my logical thinking level gotten reduced. So first, like you shouldn't get into algorithms and data structures. First, you have to understand the problem, then get an idea like what you have to do actually, and you have to simply think what you can do. Then you have to prove it like whether your idea is correct. The proving part is very important because otherwise, like after coding it, uh, if you get back to like if it's wrong, if you get back to thinking again, it's a waste of time, right? So always try to prove like whether your solution is right or not. And I mean, you don't like in practice the order doesn't matter because in practice you might have solved like multiple questions, right? So whenever you look at a problem, you kind of get an intuition what this problem is going to be like or how you can approach. But like in the beginning, it's better if you follow this order. Okay, let's solve these problems. So I kind of got an idea like uh, I can check all possible subsets here and check whether I can visit all the vertex here. So let's do it. I mean, this is my ID. I use Farm Manager, but like you can use whatever ID that is comfortable for you. I mean, choosing an ID is like biggest part in competitive programming, because like it will help you. It will help you to like reduce the time you spend on configuring the IDE and all. So it's my idea. I use it. Like I have like pre-written template and pre-written macros which I can use. For example, if I type seg, I will get this bunch of code for segment 3. Likewise, you can configure your own IDE for your own case, which will like really help you in many contests, and it will save you time. So in this problem, I need to have a adjacent series. So we created an adjacent series, and like I said, now I have to think about an algorithm or data structure which I can use to uh, keep track of the subset, right? Yeah, I can use dynamic programming because of practice. I know what I can use here. If you practice really hard, you will also get to know like what you can use. So initially, 1.0. So I use C++ as my main language, but it doesn't matter. You can use whatever language you want, even Python, JavaScript, Java, whatever you like, it's fine. But like, it's better if you know like at least 2 or 3 languages. Like, no means like you don't have to be so much good at it, but like if you know how to code some part, it's fine, because like some uh, mathematical calculation parts, if you're going to do it C++, you can do it because like C++ is very fast and like optimized language, right? But you have to implement so many things. But in Python, you can just say, like, for example, if you want to like multiply large numbers, if you want to do it with C++, you have to convert it to string, and again, like you have to multiply one digit likewise, right? But in Python, you can directly multiply it. It still work. So it's better to know like at least like 2 or 3 languages which support different kind of operations. So here, so initially, I can start at any position. So initially, a subset with one element and this DP state means like the subset of element I with ending position as j, like subset of j with subset of I with ending position as I. You don't have to like. You can try this problem on your own. I'm just like showing you how to submit and how you can get marks and all. Let me do this. Let's try this. Let's compile and see. Let's hope it works. The another important part is you have to test. Like if your code doesn't work for some reason, just check it. It's fine. I mean, you are not a we are not a legend, right? To like code every thing without any mistake. So okay, this is fine. Fast sample test cases. Let's submit and see. It should work. Let's see. Yeah, I got accepted. So after submitting, there will be some score assigned to each test cases, and based on that, you will get some score. I mean, partial scores are also good. Like even in some contests, like I can't remember contest I participated. It's like the entire contest is filled with like advanced hard questions. Like it's very hard to solve even a single problem. But the first place a team got, they didn't solve a single problem. Like they, I mean, no one solved a single problem, but they won with like partial scores. Like they got 30 for first problem, they got 50 for second problem, they got 80 from third problem. So still you can win using the partial score. It doesn't matter. So like uh if like don't like ignore a problem like I can't find optimized way to approach this problem, so I can't do it, and go to another problem. Just like at least implement a brute force solution that works. And another part, like for testing, um, testing is like an important part in competitive programming. So so if you like, I mean, it's nature of programming. Like you will uh, get into a error or something, like at least once. So in those case, like if it doesn't produce an answer which you expected, you had to test it, right? So like you had to check all the counter cases and prepare test cases for that and check. But in some scenarios, like for some hard, like large problems, you can't manually check it, right? In those scenarios, you can always create a batch program, uh, which actually checks for you. For like how that works is like you have to write a brute force solution, and like both the programs will compare each other with some randomly generated test cases. For example, here I'm generating some test cases based on the constraints, and uh, I wrote a brute force solution here for some problem, and wrote a normal solution, some large code for some problem. But like I got into an error which I couldn't figure out. I was like testing with some simple corner cases. Still, I couldn't figure out. So I can write a batch program which like iterate from 1 to 1000 and generate some. It will generate some test cases and put it into solve.in, and that test case will go into my original solution and gets a output, and it will the test case will go into brute force solution and get a brute force output. Then this FC part will compare whether there's a difference between my solution and the brute force solution, and if there's a difference, it will like print it in a file called diagnostics and exit right away. Otherwise, like it will print like over test case first. I mean, you can write your own batch program or batch program uh, or any other like scripting things which you know to test the test the program. What else I need to tell? The another important thing in a contest like SLIITXtreme or IEEEXtreme or ICPC or whatever team competition, you have to prepare a strategy for it, because like it's not a 3-hour or 5-hour competition, right? You have to stay awake for 12 hours. You have to constantly think for 12 to 24 hours, right? So it's very hard to like constantly think for 12 and 24 hours. Like during my school, like high school days, there was like several competitions which occurs like around 3 to 5 hours, which like I can like really participate alone and do well. But when I come to university, there was a contest called ASS Coders, which I first participated. Like I had confidence like I can do well in that competition because like I was really good at that time. But the thing is like when I went to that competition, like after like 6 to 7 hours, like those competition occurs during midnight, like from night till morning. So when I participate there, I couldn't like after 7 or 8 hours, I couldn't think of anything. Like even a simple problem, uh, it was very hard for me to like think of it. But in IEEE Extreme and the local extreme competitions, they will give like much annoying implementation problems, which really annoys you. So it's better to have teammates as well. Otherwise, like, I mean, at least to motivate you, even if they are not good at programming, still it's better to have teammates to motivate you to keep you awake. And another thing I have to say is when you're trying some problem and you're not getting anywhere near to that solution, just switch it to another problem. Because like if you spend too much time on it, and even if you solve that problem, and if you come back out, there will be lots of like in this kind of competition, there will be lots of problems that like that will get piled up. And like after looking at like 10 or 15 questions you had to solve, you will get panicked and like the thinking ability will get reduced. So like if you can't, um, I mean, spend some time. Still, if you couldn't figure out, like if you couldn't get anywhere near, just switch it to another problem. And while doing that, you might get a solution for the previous problem, which occurred multiple times for me. And think with your teammates and collaborate with your teammate and could do well. And I mean, even if you can't get full solution, the partial score is enough to win. So always like, don't ignore any problem. Try all the problems. Read all the problems. Because like you won't know you won't know whether it's an easy problem or harder problem if you don't read it, because like they don't put problem in easy order or some ascending order, right? They will randomly put problems. So it's better if you read all the problems, then you will have an idea like whether you can solve this or not. Because like you might be good at some area, and if the problem is about that area, you can easily solve it, right? So it's always better if you read all the problems. That's all for you guys. Good luck for SLIITXtreme. Do well. Thank you. And if you have any questions, it's time for it.
Thank you, Mr. Abhiram, for this delightful session. And like Mr. Abhiram has said, if you all have any questions regarding the SLIITXtreme 3.0 hackathon, now's your chance. Well, I guess Mr. Abhiram, from the looks of it, I think everyone has understood and are cleared on through your session. So before we proceed, Mr. Abhiram, we humbly thank you for taking your valuable time in presenting this session for all the audiences and the participants who will be participating tomorrow on October 5th for the preliminary round of SLIITXtreme 3.0. So please humbly accept our token of gratitude for dedicating your valuable time as a valuable speaker for SLIITXtreme 3.0.
Thank you.
All right, so as our session has come to an end, we would like to finalize our session with a capture the moment time. So we would like to sincerely request you all to on your cameras and use the backdrop that will be sent in the chat below. And let's take a moment of snapshot in order to remember this session of SLIITXtreme 3.0. For those who are comfortable, please on your cameras. All right. Thank you, everyone, for taking your precious time in witnessing this remarkable session conducted by two of our prestigious hosts. So in order to end our session, we would like to once again, thank you all, and we really hope that you have gathered something valuable at this end of the session, and we really hope to see you tomorrow for the preliminary round on October 5th. If you have any questions, you may contact us or one of the guest speakers, as they have shared the contact addresses. And if there are no questions, clarifications, or any more doubts, we may end the session. Thank you all and have a good day.